Good day. Today I would like to discuss with you monitoring Nomad with Prometheus and HashiCorp. First of all, let me introduce myself. I actually went to school to become a molecular biologist. That quickly turned into big data, because big data was a thing first in molecular biology, but meant I had to program, had to do statistics with code. So according to my colleagues at one point, I sold my soul to the dark side and became a dev. In academic worlds, the dev guy is almost always the server guy. So I did servers, I did academic clusters, and at some point, according to my colleagues, I sold my soul to the dark side and became an ops guy. And now that's how I'm employed as an open source consultant at a Belgian, European consultancy called Inuits. And what today we're going to discuss, this looks fairly complicated, but actually it isn't. It's a scheduler. It's something that gets stuff to the scheduler and an ingress controller, so something that you can contact with your web browser. You can pretty much still see the drawing behind me here in my home office. Let's have a look what it's all about. First of all, the ingress. It's not actually part of the talk name because it was going to be too long, but you need something that can, as I said, turn a web address into something that a server can respond to. So in my case, I'm using Traefik, which is a nice little open source tool built in Go that can transform pretty much anything into anything. It's an open source edge router that can use static or dynamic routes, and dynamic routes is what we're interested in today, because that's what Nomad's going to provide us. Well, Nomad's not going to provide us the route. Nomad's going to provide us the content dynamically. It has loads of native integrations. It can do Kubernetes. It can do Rancher, and we're mostly interested in Consul today, because Consul is the service discovery tool we're going to use. Version 2 has recently been released, and it does pretty much only Kubernetes or Consul, and they're building up to add the other stuff again. And the other beautiful thing about Traefik is that it has Let's Encrypt integration built in. So you get certificates for free, not just for free, but also the acquisition of the certificates for free. How does ingress look like? You have a simple config file where you define what port you want to listen on. In this case, 2 ports. One is a simple HTTP port 80, which we then quickly redirect to port 443, which is the one with the certificate on it. How does the certificates work? You have to add another simple config block called Acme, and you tell it that you need to expose the certificates on the certain entry point called HTTPS, and we'll turn on the host rule, which is a cool thing where you don't have to predefine all your the URLs, URIs, where you want a certificate on, where basically Traefik will listen on or for any new services exposed by the service discovery tool. And then at that point, it will create or request a ticket. You have to be careful because the first request will going to be fairly slow. And then we define where it's going to be stored. And then we define how Let's Encrypt is going to contact us about renewing or acquiring these certificates. And then, of course, the dynamic ingress. This is what we're after. Consul, we'll come back to that a bit later on to discuss it a bit further. Consul is a backend we can request services from. We expose it by default at $servers.attachmentgenie.lab, which is my local which is the local setup I have here at home, which I run all my tests, my services on. And as a endpoint, we'll choose localhost 8500 because that's always where you have your console. Well, normally you have your console node set up, and it will request services from all other nodes. And then we have a little security flag called expose by default, which will turn off, so that we have to have a conscious decision to expose the services we provide, so that something cannot escape by accident and will end up on a news website somewhere. So being a good neighbor means we need to expose our services. We need to expose also our metrics. And in this case, it's very simple to turn on. We want dashboard true, which works well in labs, but they actually advise to turn off for production setups. And then we'll expose the metrics and we'll expose ping, which is their version of a health endpoint. And then we can turn these metrics, and can turn them into nice dashboards. In this case, we're looking at a Grafana dashboard, and it exposes, for instance, how long it's been up, what's the ratio of HTTP return codes, the 200s to 400s to 500s. And it shows nice little spreads. And as you see here at the top, I reference numbers, and these numbers are the Grafana Cloud dashboards. So we can stand on the shoulders of giants or other people, and we can easily use these dashboards created by others, and then turn them into, use them for ourselves, or modify, update, and release back to the community. And then it leads to consoles. So we first have ingress, then we have the service discovery, which we're going to look at a bit more in detail. Consul is a service discovery tool created by HashiCorp. It can act as a DNS server, so I can actually dig my local Consul node at port 8600, and then I can dig it for a certain service that it knows about. It has a built-in key value store where we can store data, and it also has gained the ability to be service mesh. So it uses Envoy to expose services, and it can use ACLs to actually stop people getting to your services. What does it look like? Well, how do I set it up? What does it look like is a different story. But how do I set it up? In my case, we are a heavy user of Puppet, so all my code examples will be Puppet based. In this case, I'm setting up a Consul service for the Traefik UI, so the dashboard, which listens at port 8080. And then for every service, we need to create checks for Consul to know that your cluster members or your application is actually live. So in this case, I'll create a check for Traefik HTTP. I'll check it every 60 seconds, and it basically does a simple check on a certain endpoint. In my case, localhost 8080, and it matches up to the service ID Traefik UI. So that's how it links the two. First, look at HashiCorp. HashiCorp is a very cool alerting tool, monitoring tool, and as chance has it, Consul checks actually use the same exit code as HashiCorp checks. So if you have a pre-existing HashiCorp checks for your services, you can actually pretty much directly inject them in as a Consul check. In this case, my little Traefik status HashiCorp check, which again links to the Traefik UI. And in this case, I'm checking a bit quicker every 10 seconds. How do we expose the telemetry? So how do we get metrics? In this case, it's fairly simple by saying Prometheus retention time is 30 seconds, and then disable hostname. So the hostname is true. Well, disabling hostname is true because there's other metrics systems that Consul could expose for, and then they use the hostname, but in case of Prometheus, we don't need it. What those dashboards look like, again, 2351 on Grafana Cloud. We know how many nodes are in the cluster, how much CPU pressure there is. We know how much TCP and UDP messages are going around, and how our elections go. And then it brings us to Nomad, the meat of the talk, or the meat of your container platform. Nomad is an open source tool created by HashiCorp, which can deal with dynamic workloads and schedules it as batch jobs, containerized jobs, or non-containerized Java jobs, for instance. And the beauty of it, it has native console and Vault integration. So you can have an easy way to connect your container load or your workload with console to things like Traefik. And you can very easily do for secret management. Secrets, of course, are never easy, but Vault integration with Nomad makes it as easy as it comes. How do we expose the Nomad metrics? It's a bit more work than for console, but it's pretty much still the same. It's a bit of HCL code to expose the telemetry. We'll again disable the host name, and we'll expose Prometheus metrics. Dashboards, there's a couple floating around. This one's really interesting to us because it again shows fairly simple metrics: the CPU load, the memory, how much disk we're using, and where the jobs actually are shuffling around. So as an example, I'm gonna talk our way through deploying our little blog application. So there's this is the definition of a Nomad job of type cold blog, and it's gonna be of type service. It has a little group with one task in it, my Nginx task, which is a Docker image that comes from my private Docker registry. And we're gonna explore something is gonna listen on port 80. To turn this into something that we can expose with Traefik, we have to define a service unimaginably called blog. And if you remember me saying, I don't want to expose something by default in Traefik, to be able to expose it now, I need to add a tag called Traefik.enable equals true, and then Traefik will expose it for us. And it needs to be linked to port 80, to the port that we defined before, the HTTP port. And here, as a check, which is actually the console check, that we'll have something simple, basically saying something needs to listen on TCP, and then we're going to check every 10 seconds. And enable to not destroy the thing we're monitoring is just time out after 10 seconds if it's not going to work for you. What does this look like? This is the Consul UI, which is a nice tool. You can check what your services are doing, how many you have. And the beauty of Nomad is it actually injects a little bit of metadata so that Consul can mark your services that are served by Nomad from the Consul UI, which is the little green icon you see on the left of every name. So here I have 5 services being served by Nomad. Well, actually 4, because the 5th one is Nomad itself. What does the UI look like? This is the Nomad UI that is with our job, still called blog, and it actually shows you how many times that were deployed. In this case, I've been tweaking it a bit, so I have 6 failures before I managed to get my first one to pass. And it shows you the allocations and where the task is running on which client. If you zoom in, you can actually see what the utilization is, and of the utilization of your job is, and you can see where your task is exposed. So in this case, it's on a local IP on a dynamically assigned port. So coming back to the original problem, we have dynamic problems, and normally, or traditionally, when you use these tools like HashiCorp, it's pretty static landscape. So it doesn't matter too much if you take a while to get all your checks in place, or to get checks in place, alerting in place, that kind of thing. Now with Nomad or Kubernetes, but especially Nomad today, we have a lot of dynamic stuff, and services might last for a lot less long than we're used to. So we need to tweak the way we handle alerts a bit than what we're used to. In that case, I created a little HashiCorp plugin that will actually directly query Consul and then starts to create services and nodes. Again, we stand on the shoulder of giants, so I use a library that was created by the same people that created the Symfony framework. It doesn't actually need a lot of code. So I start a little service which connects to Consul, which I query. I get the catalog content, which is the same as typing Consul catalog on your CLI, and we get the same list, but it's now JSON, which we decode. And then we can actually get the list of nodes, of Nomad's nodes, because that's pretty much in our case, the dynamic bit of the platform. Your ingress is pretty stable, your Consul will be stable, but the amount of Nomad nodes, if you set it up right in a cloud like Amazon or Azure, it can actually be an auto-scaling group. And in this case, we need to know how to get these nodes in. So we wrote the code, and now we need to import them into HashiCorp. The plugin I wrote is an HashiCorp Director plugin, which is a mechanism they've come up with to have more dynamic loads than previously. And here we're going to set it up. I'm going to define an import source called Consul, where we define where my Consul lives. Defaults are probably fine. So at localhost 8500. And then we need to have a sync rule in place which says what is the action that needs to be taken based on the data that's coming in. So in my case, we're finding hosts. So I need to build something of type host, and I'm going to replace whatever. My default action for an update is replace. So just flush the old in with the new, and when something goes away, we'll purge it, because my Nomad nodes are very dynamic in this way. It's not because something is going, when something goes away, it actually goes away instead of it going missing. To see. Then we need to map some stuff from the JSON blob that comes in, and we need to assign a default template. And template is a group of checks that we automatically assign to nodes. And in my case, it's a poorly chosen name called dummy, but it's actually, it contains the default checks I have for Nomad nodes. So is the service running, how my CPU is doing, is Docker running, that kind of stuff. And then we need to set up an interval, a timing interval. So in this case, we'll check every 10 minutes, and then we'll, and every 10 seconds, sorry. It runs every 10 seconds to work out if there's new nodes or not. We can do it a bit more elaborate, where we can actually go look for services. So if the services are really dynamic and we want to specifically check the services, it's a bit more elaborate, but it's still not that hard. We ask for the amount of services, which we obtain from Consul, and then we work our way through the information. Because if you remember, I said Nomad adds a little bit of metadata to distinguish its jobs as Nomad jobs, and then we can work out where we know where the metadata key is, so we can actually ask for it and we can query for it. And that way we can have a distinguished list of Nomad services. And so if we want to work out where our service is actually running, most of the time we don't care so much, but especially when it's running in 2 data centers or multiple nodes, and you want to work out what's where, or if you want to work out is your service actually down. Sometimes if we create a service, we'll say we want to have an version of the service running. So if I lose one, I don't care that much. Sometimes when I lose one, we're actually in trouble. So for that kind of stuff, HashiCorp has a thing called the business process engine, which here you see a very simple example. I've modeled here 2 services, one called Barbar and one called Barbecue. And we can actually pretty easily modify this ourselves. The business process dashboards you've seen in the slide before actually has a fairly simple TSL. So we can build these ourselves on disk every time Consul sees a little, sees any change in the service. For this, we can set up Consul Watch. So Consul watches a service. In my case, it watches a service, the service called Nomad Client, which means every time a Nomad node comes into operation or goes away, this template gets updated. For that, we use a script called update, a business process, and well, it needs to be in place. And that's actually the end of my talk today. You can email me, and I'm at Attachment Genie on pretty much any social media, including SlideShare, where I'll make sure these slides are uploaded. Thank you.